Welcome to the tutorial on the slope of parallel lines and perpendicular lines. What are parallel lines? Parallel lines are lines in the same plane. So when we talk about graphs, we're talking about lines like this first example here. The blue and the red line are parallel, they're in the same plane, and they do not intersect. Also, parallel lines, they're lines that have the same slope. Now, we've already seen tutorials on how to calculate slope. So let's show how this is actually true. So let's look at this first example. We have the point here and here. If we look at these 2 points, the first point here is 3, 3. The second point, that's lower down here, is 2, 1. So our formula for slope is y2 minus y1 over x2 minus x1. And we know we have 3 minus 1 divided by 3 minus 2. And that means our slope is 2 over 1, or simply 2. So the slope for M2 is 2. Now, let's take points on the blue line, or M1 line. Let's look at these 2 points. So we have the point minus 1, 0. And of course we have this point here, which is minus 2, minus 2. And again, we're going to put them into our slope formula, which is y2 minus y1 over x2 minus x1. We have 0 minus minus 2 divided by minus 1 minus minus 2. So of course that gives us 0 plus 2 divided by minus 1 plus 2, or 2 over 1, which is equal to 2. So the slope of M2 of M1 here is the same as M2. So M1 equals M2, which is equal to 2. They're parallel. The slopes are parallel. The slopes are the same for parallel lines. Now let's look at this second example. We have 2 vertical lines, M1 and M2 in purple. Now, I know, based on our definitions of slopes, that M1, because it's a vertical line, the slope is undefined. I also know because M2 is vertical, the slope is undefined. So M1 equals M2, and both equal undefined. Now let's confirm by looking at the equations of the line. So let's take our first example and figure out the equations of the line. If I wanted to look at the equation of the line for M1 in our first example, or I'm going to call it L1, actually. So let's call it L1 so that so our L1, we have slope of 2. And let's use the point, this one here, minus 1 and 0. So the equation of L1, if we use our point slope form of a line, we have y minus 0 equals 2, x minus minus 1. So I have y equals 2x plus 2. So that's my equation of the line. Now let's look at line 2. So again, my M2 is 2. let's use the point 2, 1. I have y minus 1 equals 2, x minus 2. So I have y equals 2x minus 4 plus 1, or y equals 2x minus 3. So what do we have here? We have slope the same and a different y-intercept. That is the only difference. And of course, we can see here, there's our y-intercept of minus 3. And I have y-intercept of 2, which is exactly what we have in our two equations. So, parallel lines, same slope, different y-intercepts, which makes sense. Now let's look at perpendicular lines. So of course these are lines that cross each other at a right angle. So there are two lines, whoops. And again, they intersect at a 90-degree angle. Or we like to call it in trigonometry a right angle. So what's going to happen with these two? Okay, let's look at our points. So on the line, the blue line here in our first example of M2, I have the point 0, 2, and I have the point 2, 1. On the line M1, I also have that point 2, 1, but I also have the point of 0, minus 3. Okay, so let's go ahead and figure out what these slopes are. Let's take the line M1. So our line 1 here. For M1, of course, again, y2 minus y1 over x2 minus x1. And we're using the points 2, 1, and 0, negative 3. So I have 1 minus minus 3 divided by 2 minus 0, which gives me 1 plus 3 over 2, which is 4 over 2, which is equal to, of course, 2. So the slope for line 1 is 2. Let's look at the slope for line 2. Here's line 2. So M2, again, y2 minus y1 over x2 minus x1. I have, using my points, 2 minus 1 divided by 0 minus 2, which is equal to 1 negative 1 over 2. So the slope of M2 is negative 1/2. Now, if I look at these two lines, I know that M1 times M2, what does that give me? I have the slope of 2 times negative 1/2. Of course, that gives me negative 1. So these slopes of perpendicular lines, there's our symbol for perpendicular lines, are negative reciprocals. And how do we do the check? Exactly what I did here to see that we get a negative 1 as the answer. So of course, 2 over 1, which is this one here, is the negative reciprocal, what is it for it? Is negative 1/2. Now let's look at horizontal versus vertical lines. Well, I know that, again, remember, my vertical line has an undefined slope because it's a fraction with 0 in the denominator. I know that my horizontal lines have a slope of 0 because 0 is in the numerator. Because they're on opposite sides, they're again like reciprocals. And it doesn't matter if it's a negative reciprocal or not with those, because with m2 equaling 0 as the slope and m1 being undefined, these are considered negative reciprocals because of this fact that we have an integer up here and an integer in the denominator for the other one. So because these zeros, again, are on opposite sides, they're considered negative reciprocals.